Hey everyone, this week we're going to be talking about solving logs and exponential functions, and we're also going to be including some real world examples. So we're going to start with solving exponential equations. I'm going to give you some steps to follow first, and then we'll work on actually solving the examples on the left side. So if you are unable to have the same bases, then you're going to want to first isolate the exponent and the base it's touching. Step 2, you're going to want to remove the base the exponent is touching or is attached to by taking the log of both sides. And then you're going to want to solve for x. Okay, so just for a quick reminder, I want you to remember that log base e is the same thing or is equivalent to the natural log. Our first example, 10 equals 5 times e to the 4x power. Remember the first step says that we need to isolate the exponent and the base it's touching. So for here, our exponent is 4x, and it is attached to the e. It is not attached to the 5. It is being multiplied to 5. So what we need to do is get rid of the 5 by dividing both sides of this equation by 5. When we do that, the 5s go away, the 10 and the 5 make 2. So now we have 2 equals e to the 4x power. So next we're going to log base both sides, but in this instance we're going to ln both sides, which will make the e and the ln cancel each other out, leaving us with ln of 2 equals 4x. So then next we're going to isolate that x by dividing both sides by 4, leaving us with x equals ln of 2 divided by 4. Let's go see what the decimal equivalency is in the calculator. Hit ln on your calculator, put 2 inside the parentheses, then divide by, and then 4, hit enter. You can also do alpha y equals, create your fraction on number 1, then you can do ln of 2, and then 4 in the denominator, hit enter, and you should also get the same answer. So taking our decimal to the thousandth place, our final decimal version would be 0.173. So for example number 2, 5 to the x power minus 4 equals 7. We need to isolate the base that has the exponent attached to it by adding 4 to both sides. This will then give us 5 to the x power equals 11. And then next we need to log base 5 on both sides, and that would get rid of the base of the exponent, leaving us with x equals log base 5 of 11. So now that we know what x equals, let's use our calculator to get the decimal equivalency and see what that will be. Hit math on the calculator, arrow up twice to log base, hit enter. Then you're going to enter 5 for the base, 11 inside the parentheses, and then hit enter for your decimal. So let's be consistent with rounding. So we're going to round to the nearest thousandth. Make sure when you're looking at your answer, in here we have, it's a 9, so we're going to look to the right. It looks like it's an 8, so make sure you round up properly, giving us our final answer is x equals 1.490. Looking at example 3, we have 6 to the 3x minus 9 power minus 10 equals negative 3. So let's isolate that 6 base. We're going to add 10 to both sides. So that gives us plus 10 on both sides, leaving us with 6 to the 3x minus 9 power equals 7. Now we need to log base both sides, log base 6 both sides. This will get rid of the base and the log, and that now leaves us with 3x minus 9 equals log base 6 of 7. Now here's where it kind of gets weird. If you want to make sure that you put in the calculator correctly in just a second, I would go ahead and put 7 in parentheses, because we are going to need to move the 9 over from the other side. So we still need to isolate the x because that's what we're solving for. So plus 9 plus 9. Notice it's going to go at the very end of our log expression. and that will give us 3x equals log base 6 of 7 and then plus 9 on the very end. I like to do everything at one time in the calculator. So continuing on, I'm going to divide both sides now by 3. And we'll finally get x equals log base 6 of 7 plus 9 on the outside all over 3. Again, we're going to need to look and see what our decimal equivalency will be. So we'll have x is approximately, let's go throw it in our calculator and see what that is. I'm going to create a fraction. So alpha y equals, hit enter. Then you're going to go to math, arrow up twice for log base of 6, put it in the bottom, then 7. And then arrow on the outside, put plus 9. Then go to the denominator and put your 3, then hit enter. So rounding to the nearest thousandth, our answer is approximately 3.362. Okay, so moving on to solving logarithmic equations, we're going to go over the steps. The first thing that you need to do is move all the logs to the same side of the equation. And then you're going to condense the logs if needed. Afterwards, you're going to exponentiate both sides using the same base as the log. And then you're going to solve for x. Then you're going to check for extraneous solutions, which means if my answer, my solution I come up with, if I plug it into my original equation, will the log of that value be negative? And if so, you have to remember that you cannot take the log of a negative number, meaning that it would not be a valid solution. So for our first example, we have 7 plus the log base 3 of 5x minus 4 all equals 10. The first step says that we're supposed to consolidate or condense logs if we can. There's nothing to condense. They're all on the same side. So the first step that we're going to do here is subtract 7 on both sides. When we do that, the 7s will cancel, and then I'm left with log base 3 of 5x minus 4 equals 3. And then the inverse of a log is an exponential, so we're going to exponentiate both sides using that same matching base. And then so the log base 3 and 3 go away, and we are now left with 5x minus 4 equals 3 to the third power. Well, 3 to the third power we know is going to equal 27. So we have 5x minus 4 equals 27. Let's get x by itself. So we're going to add 4 to both sides. So now we have 5x equals 31. Divide both sides by 5, giving us x equals 6.2. Now, to check this answer, this solution that we came up with, this 6.2, to know if it's valid or not, we're going to check to see if it's extraneous, meaning that we're going to plug this back in up to this, in the parentheses, this 5x minus 4 section right here, because it's the part that's attached to the log. So if we take 5 times 6.2 and then we subtract 4, we need to make sure that it's not going to be a negative value. Let's just simplify. So 5 times 6.2 is 31. If we take 31 minus the 4, we know that that's going to be still greater than 0. It's not going to be negative, so we have 27, making this a good solution. Our next example, log of x plus 9 equals 1. Looking at our steps, it looks like we don't need to really do step 1 because the logs are on the same side. We do need to go ahead and condense. So if you can recall, the plus in the middle of the two logs will mean that we're going to multiply. You're going to multiply the x times your x plus 9. You will only write the word log one time, so we have log of x times x plus 9, and all of this is actually inside of parentheses, equals 1. So now we have log of x squared plus 9x equals 1. because don't forget you need to distribute this x to everything inside. So that's where the x squared plus 9x comes from. So now you need to get rid of the log by exponentiating both sides. Remember the base is 10. So base 10, if you don't remember. So the log base 10 and 10 will cancel. And then you have x squared plus 9x equals 10 to the 1 power equals 10. Now remember, we're going to have to move this 10 over because it's going to make a quadratic because you have an x squared and an x. So let's go ahead and subtract 10 on both sides. Make sure you put it in the right location. It is a c value when it moves over, leaving us with x squared plus 9x minus 10 equals 0. Now you need to check to see if it's factorable. I know it is. So I'm going to go ahead and create our two factors. We're going to have x plus 10 and x minus 1. Set each factor equal to 0. And then you're going to solve for x, giving us x equals a negative 10 and x equals a positive 1. Now remember, we need to make sure we check for extraneous solutions. Meaning, if I were to go back to the original problem and I have a log of x and then I had a log of x plus 9. If I plug in my current solutions into either one of these and ever get a negative answer, then it would not be it would be extraneous. It would not be a valid solution. So we can plug in the negative 10, giving us log of negative 10, which right away that does not work. So we can go ahead and dismiss the log or negative 10 as a solution. So we can go ahead and cross that one off. Then we can try the 1. Let's try 1. So we have log of 1. That will work. And then let's go double check it in the other one. So we have log of 1 plus 9. That would give us a positive 10. That will work as well. So the only solution that is acceptable would be this x equals 1. So on our next example, we have log base 6 of x minus 5 equals 2 minus log base 6 of x. In this one, our first step says that we need to make sure our logs are on the same side of the equation. In this case, it is not. We need to move one of the logs to the other side. I'm going to move the log base 6 of x. So I'm going to add log base 6 of x to both sides. You can only do this when the bases are the same. This gives me, now we have log base 6 of x minus 5 plus log base 6 of x equals 2. So now we need to go ahead and condense our two logs, because don't forget we have a plus in the middle, means that we're going to multiply, and we're going to multiply the x minus 5 and the x together. So when we go to write it, we're going to have log base 6 of x times x minus 5, close parentheses, equals 2. Don't forget to distribute this x. So now we're back to log base 6 of x squared minus 5x equals 2. Let's go ahead and get rid of our log by exponentiating both sides by a 6. And then the log base 6 and 6 will cancel each other out, leaving me with x squared minus 5x equals, now you've got 6 to the second power, which is 36. Let's move that 36 over to the other side, so minus 36. And now we have x squared minus 5x minus 36 equals 0. We do know that this is a factorable quadratic equation, so we're going to have two factors, and we know factors help us find solutions. Our factors will be x minus 9 and x plus 4. Make sure you set them equal to 0, giving us x minus 9 equals 0, x plus 4 equals 0. And once we solve for x, we know that x is going to equal a positive 9 and x will equal a negative 4. So remember, we're going to check for extraneous solutions. We're going to check for the x equals 9 and the x equals negative 4. We need to check. We have the log base 6 of x minus 5. And then on the other side, you also have your log base 6 of x. So if I take the 9 and I plug it into the first log, so if I plug in 9 for x, 9 minus 5 is 4, so we should be good with that one. If I take log base 6 of 9 and the second one, it would also work. So I could plug in 9, that works in that one. If then I could take the negative 4 and plug that one in. So if I plug in negative 4 in this one, negative 4 minus 5 equals a negative 9. That is not going to work. And at that point, if you know it's not going to work in one of them, then you don't even need to try the other ones because it's not going to be valid regardless. So we now know x equals negative 4 is not a valid solution. It would be considered extraneous, and our only good solution would then be x equals our positive 9. Okay, so our final log equation that we're going to solve is ln of 8x equals ln of 2 plus 5. Here we are going to have to move our logs to the same side, in this case our natural logs. So I'm going to subtract ln of 2 on both sides, giving us ln of 8x minus ln of 2 equals 5. Next, we're going to want to condense, so we're going to write the ln one time, and since we have a minus, that's going to make us have a division between them. So we'll have ln of 8x over 2 equals 5, and then we're going to exponentiate, or the inverse of ln is an e on both sides, so ln and the e cancel, leaving us with 8x over 2 equals e to the 5th power. Now, I can simplify the left side, 8x over 2. That will become 4x equals e to the 5th power. Just keep in mind you're solving for x, so that means I need to divide both sides by 4. And then we're going to have x equals e to the 5th over 4, or divided by 4. All right, so at this point, we just need to throw this in the calculator and come up with an answer. If you can't remember what to do, you're going to want to do seconds and then do the little division symbol. These are both buttons on your calculator. And the little E that you're looking for is located right above that division. So hitting second and then the division will give you that E. And then you can just raise it to the 5th power and then divide by 4. So to give us our approximation, our x is going to equal, or be approximately, 37.103. Don't forget, you still need to check to make sure that this solution is not extraneous, meaning that when I go plug it back into the original equation, up here in the top where this 8x is, if I take this positive value and multiply it by 8, it's still going to stay positive. And there's nothing else on the other side that I need to check. So this would be considered a good, valid solution. So moving on to some real world examples. You deposit $250 into an account that pays 4.5% compounded quarterly. Determine how long it will take for the account to contain at least $500. If you can recall, it talks about something being compounded quarterly. There was a formula that we worked with not too long ago. It's our compound interest formula. It was A equals P times 1 plus R divided by N to the NT power. So the first thing I'm going to do is go through the word problem and underline important parts. So you deposit $250. This would be our initial deposit, so that would be our P, into an account that pays 4.5%. Now that's a percent. Remember, you need to turn that into a decimal. So you can move this decimal to the left 2 places, giving us 0.045. Compounded quarterly. The word compounded is the big giveaway that you're going to use. That's our end. Quarterly means how often it occurs within 1 year. So quarterly means 4. So our N will equal 4. Determine how long. So obviously how long is what we're trying to find. We are looking to find T, the amount of time it's going to take our account to equal or be at least $500. So this 500 would be our A. I'm going to now go ahead and plug in everything in my formula and write it all down. So we know we have A was 500. So 500 equals our P was 250. So 250, open parentheses, 1 plus our rate is 0.045 divided by our N value, which we decided was 4. Close parentheses to the 4 for N times our T, which we do not know. That's what we're trying to solve for. Okay, so to get the T by itself, we need to divide both sides by 250. And when we do that, the 250s cancel. 500 over 250 gives us 2. So we have 2 equals parentheses 1 plus 0.045 over 4, close parentheses to the 4t power. Now when we do this, I do a couple of different ways sometimes, but if you can plug in what's in the parentheses into your calculator and it will give you not too long of a decimal, then I say go ahead and simplify it further. And in this case, it does give us some decent decimal. So we have 2 equals parentheses 1.01125, close parentheses to the 4t power. Now that parentheses is now your base. And so now we're going to have to log base both sides. So we're going to log base 1.01125 on both sides because we want those to cancel. So I'm going to continue writing over to the side a little bit so I have more room. So the left side, we're going to have log base 1.01125 of 2 equals the log base and the base will cancel, and that's going to leave us with 4t. From here, you still need to get t by itself, so you're going to divide both sides by 4, and that's going to leave us with t equals log base 1.01125 of 2 all over 4. Then plug that information into your calculator and get the value once you hit enter, and that will be our approximate amount of time. So t will be approximately 15.489. Let's simplify that to approximately 15.5 years for our money to double. Here we are with our last real-world log problem. So it says the difference between the apparent magnitude or the brightness is lowercase m of a star and its absolute magnitude, uppercase M or capital M, is given by the formula lowercase m minus capital M equals 5 times the log of d divided by 10, where d is the distance of the star from the Earth, measured in parsecs. The star Antares has an apparent magnitude, so apparent magnitude, and up here it mentions that apparent magnitude is the lowercase m, so we know that this is m is going to equal 1.0, and it has an absolute magnitude. An absolute magnitude is mentioned up here. It says it's represented by the capital M. So that will be our uppercase M is negative 5.3. Find the distance. So this is what we're looking for. We're looking to find D of Antares from Earth. And it says round our answer to the nearest parsecs. So let's plug in our information that we're given and solve for the unknown. So our lowercase m we said was 1.0 minus our uppercase M, or our capital M, which is negative 5.3 equals 5 times the log of d, which is distance, we don't know what that is, divided by 10, close parentheses. So if we take a look at this, we're going to simplify where we can. It looks like on the left side we can do a little bit of simplifying. So we have 1 minus a negative 5.3, which is actually 1 plus 5.3, which gives us 6.3, because a minus a negative is a plus, equals 5 times the log of d divided by 10. Now, again, we're trying to isolate the log. So that means now we're going to divide both sides by 5. The 5s will cancel, and that gives us 6.3 divided by 5. And that's going to give us 1.26. So 1.26 equals the log of d over 10. Now we need to get rid of this log. The only way to get rid of the log is to exponentiate both sides by the base of the log. Our base of the log is not written, but it's understood to be a 10. So we're going to exponentiate using 10 on both sides. So now we have the 10 and log base 10 cancel, giving us 10 to the 1.26 power equals d divided by 10. I'm going to go over to the side so we have a little bit more room to work and rewrite our problem. So we now have 10 to the 1.26 equals d over 10. I'm going to go ahead and simplify the left side. We have 10 to the 1.26. I'm plugging that in the calculator. It's going to be approximately, I'm going to go ahead and round to the nearest thousandth. So we have 18.197 equals d divided by 10. Here we can multiply both sides by the denominator, and that will give us d by itself. So d equals 10 times our 18.197, which would give us 181.97. Our directions say to round to the nearest parsecs. We're going to say that distance is approximately 182 parsecs from Earth.